Welcome back, guys. Today in this one we're going to be cracking into a flying AI tutorial. So let me just show you what we've got going really quick. Basically what we're going to be building is we're going to be building some behavior tree tasks inside of a behavior tree that'll allow any blueprint that inherits from a character blueprint to be able to disable all their gravity, fly around in the air, roam for different flying locations while they're looking for a player, and then once they see the player they'll hover above the player or near the player. And I guess what you could integrate with that if you were building this for a game is you could have them hovering above the player while dropping bombs, you could have them hovering above the player while like shooting some sort of projectile, or you could do something non-violent and just have them hover above the player and shout friendly compliments, but we don't tend to do things like that in games for some reason. So here's a brief run through of what we're going to be doing today. Some of this stuff will be carrying on from previous tutorials, but really not much at all, and I'll explain as we go what I've created in previous tutorials, and I'll show you how it works so that you can quickly build it for yourself, so you don't need to have watched any of the previous videos to follow along with this. This is just what we're going to be doing. So we're going to be building a roaming, find a roaming point task. We're going to be building a task to adding velocity or adding a force towards that point. We're going to be setting up all of our parameters inside of a component rather than on the behavior tree. So the reason that we do this, which you'll see later, it'll make more sense later, is so that we can reuse all of these tasks across different actors, so that you don't need to rebuild anything to implement this exact same logic for different AI, and not even just in the same project. Like, you could migrate all of this to a separate project, like a new project you're working on, and you could still reuse this flying AI system. So once you've got all of this set up, you only need to do it once, and then you can reuse it again and again and again and again. So then we'll build a flying above the player task, and we might build a patrolling system at the end where you can set up particular patrol points in the world and have your AI go to each of those points until they find the player. And then what we'll do in the next video, which we won't do in this one, is we'll build a Skywatcher Guardian from Breath of the Wild. I set up a Guardian on the ground in a previous video, so what we're going to do is we're going to make him start flying around now. So let's just crack into it and let's just get started. So this is just an empty map. First thing I'm going to do is I'm just going to save this, and I've got a folder in here just called Behavior Tree for this tutorial series where everything is just going inside of that. So let's just put that in there and just say Flying AI. And then this map is just going to be Flying AI map. I'm going to make the ground a little bit bigger, so I'm just going to hit 5 down there, reset the position to the default, and then that should be good to go. Now, where's my Flying AI folder that I just made? There it is. Okay. So in here, the first thing that we'll do is we'll go new blueprint class, and we'll go type character. We want this to be a type character. Just trust me for now, and I'll explain as we go why. So this is just going to be our Flying AI BP. Let's open that up. We'll just make him really simple. So I'm just dragging that tab up there and then docking that just there like that. So I'm going to add a static mesh component just so we can visually see where this guy is and what he's doing. And we might just make him a sphere. Actually, you know what? Let's make him a cone. I'm in a cone sort of mood today. And we'll have him facing like that. So that's his forward vector, so we know which way he's facing. And this capture component, I might just make that a little bit more legit. I mean, this really doesn't matter. You can fast forward if you want. Dope, that'll do for now. Okay, so what we need to do with this guy is we need to click on the Flying AI up here, AI controller class. We're going to go my AIC and auto possess AI to spawn, place.spawn in world. Now the my AIC we set up in the first tutorial in this series, and basically that's just a custom AI controller that has some pawn sensing built into it. So if you want to set that up, go back and watch that video. It's really simple what we've done. Or maybe not. It's got a few things. All it does is run a behavior tree and then just set some blackboard keys on that behavior tree. That's literally all it does. And then we've just set up some pawn sensing down there. And we've got a custom pawn sensing video that you might be interested in watching as well. But that's all that's going on in here. Otherwise it's just a normal AI controller. So we're using that, and because we're using that, the first thing that we're going to need to do is to just call that from here. So let me, instead of just typing it all out, I'm just going to go back to something we made in a previous video, the Guardian BP. Give that a sec. Now in the event graph, okay, so I'm just going to copy this here. I just put that in. So what this is doing here is literally all this is doing is, because we've set the AI controller class to my AIC there, we're getting the AI controller, which is my AIC, casting to my AIC, so we have access to the events in that blueprint. So for example, this setup AIC here, which is this event here, which then runs the behavior tree and sets the behavior tree variables and etc. The reason that we use the same AIC for all of these things, I forgot where I was going with that completely. Oh, it doesn't matter. But the point is that you can have a different behavior tree here. You can feed a different behavior tree into the AIC. Okay, so I was going to say the reason that we use the same AIC for all the AI is because then we only have to build the pawn sensing once, rather than building the pawn sensing in every single AI blueprint. You can just build that in the AI controller, and then you can just set it up using a unique behavior tree that comes from the specific AI, and then you can run a unique behavior tree and have a pawn sensing set up. So that's just nice and reusable. You want to reuse stuff as much as you can to save yourself time when you're building games, because otherwise things just get so fucking complicated and just take way longer than you need. So now that that's running, that'll be running a behavior tree which we haven't set up yet, and it'll be pawn sensing for the target player pawn. So let's go back into our folder, the flying AI, and let's just create a behavior tree for him. So if we go AI behavior tree, this can just be called flying AI BT, and I think that's all we need. We've already got a blackboard that we set up earlier. I like to use the same blackboard for everything as well, because it just means you can reuse the same tasks and have same access to all the same keys. So that's just AI BB like that, and that doesn't want to update. Okay, there we go. So that's just all the keys that we've set up. They're just like generic shit, like each blackboard saves an origin where the actor begins play, a reference to itself. It's just got a generic cooldown key that you can set from your AI controller, which I might not have set, but you can set that to change the way that the behavior tree runs and etc. But anyway, let's get into the flying AI. I feel like I'm going off on a fucking tangent. So this is our flying AI, but before we change the behavior tree, let's just make sure that this is actually running the behavior tree. So flying AI BP, you just want to set behavior tree to flying AI BT. And that's just of type behavior tree, a variable down there. So now that should be running this like that, and this is just saving the target in the blackboard here. So the target is the pawn sensing target, which comes from here, which is the player pawn, and it's also saving the origin, which is a vector. Origin. So that just gets the location at begin play, just like that. Okay, so now that we've got that, let's just set up the gravity and everything for this guy. So if we go to character movement, we just want to disable his gravity because he's flying. So we set gravity to 0, and then if I think you might need to click on capsule component as well, and just click disable gravity, or enable gravity and untick it. So now let's just chuck him in the world and see if he actually floats. So I'm just going to drag him up like that. I might just turn my snapping back on. This is feeling a little bit laggy today. I hope this isn't too bad, but let's just jump in and see. Okay, so he's flying. That's cool. So now that we've got that, let's see, what do we want to build first. So we set up the no gravity. Find valid flying location. Okay. So go into your behavior tree. The first thing that we're going to do, well, let's just set this up a little bit. So let's have a selector. Now a selector selects the highest priority task that with a condition that allows it to be selected. So it runs from left to right. It'll stop on the first thing that can actually succeed, and it'll execute that and then repeat from the root. So let's put all the way over on the right. We'll have a wait. So if all else fails, we'll just wait for a second and then we'll try again from the root. Now, higher priority to the wait, we're going to add this. We'll have a sequence actually, and this can be called our roaming sequence. Random roaming sequence. And what we're going to do in this is the first thing that it's going to do is find a roam to location. The second thing that it'll do is it'll move to that location. And then the third thing that it'll do is it'll wait at that location. So a sequence is different from a selector. Selector tries to find the top priority thing and runs that and then succeeds. A sequence will run everything from left to right and then it'll succeed. And then it'll repeat from the root. So what we want to do is we want to create a new task. Oops, and I just used the wrong parent. So let me just delete that. Can I delete that? No, I don't want to force delete. God. The only reason I don't like force deleting, by the way, is because it closes all these tabs. I'm pretty sure you're not meant to do it for other reasons, but that's the biggest concern for me, honestly. So BTT task blueprint base is the one that we want. And now if we go back into our content browser, rename that. I'm going to call this find valid flying location, BTT. Alright, let's open that back up. Receive execute AI. Grab a reference to the control pawn. Now, the first thing that we want to do is we want to do I guess we want to pick a random location first. So let's pick a random location. So there are a number of different ways that we could do that. I'm just going to say let's get a random vector of a random length in any direction. And maybe we could cut out the Z value so that it always stays at the same elevation. That could work pretty well. Anyway, so let's just say, actually let's go down here. Let's just say get random, get unit direction vector. Now surely there's like a random unit vector, that's what we want. So let's get a random unit vector. Let's split that. Maybe let's just cut out the Z value. So we'll say make vector. And just holding control drag to drag that pin across like that. So we're stripping out the Z value. So this is just a random vector in some X and Y direction. Then what we'll do, because we stripped out the Z, we'll normalize that. So now it has a length of 1. And now what we'll do is we'll multiply it by a float. And the float can be a random float in range. Maybe we can have a variable which can be called min distance and then max distance. So we'll make these both public like that, and we might just give them a default. So the min distance that you can move could be like 500, for example, and the max distance of that vector could be like 1000. So it'll find a random a vector of length between 500 and 1000 in any random direction from where we are. So that's the next thing that we need to do, is we need to add this vector to our location. So we'll grab our controlled pawn reference and drag that in. This is why it's useful to cache these off and to save them, because otherwise we'd have to drag this all the way over here and make a big spaghetti mess. So let's say get actor location from there. Oops. Get actor location. And then I think that should be it. That should be a fully valid location. This will get us an X or Y value. This will get us a vector location, sorry, at the same Z value that we're at, because this is a Z value of 0 here, and we're adding it to our location. So it'll always, the flying AI will always stay level while it's roaming. So what we could do actually is let's just promote this to a function and just call this get new roam location, like that. And let's drag this over here and put a return node and then plug that vector into there, and this could be called new provisional roam lock. And actually let's rename this and call it get new provisional roam location, because we need to run some tests on this to figure out if it's a legit one. Now let's tick pure there as well, just so it goes green and we don't have an execution pin. And we could promote that to a variable, I guess. Or maybe what we should do is we could probably just feed that straight into a function. So what if we just say box trace by channel. So now what we're doing here with this is going to give us a location, a potential flying location that we're going to test. And the test that we're going to do is we're just going to see if the collision bounds that overlaps our flying actor can get to that location without any overlaps being triggered, then we can fly to that location. If this box that we're going to be tracing with hits whatever obstacle, then if we apply direct force to that location, we're never actually going to get to it. So then what we'll want to do is we'll need to find another random location and we'll try again. And this will just run like, typically this will run anywhere between like 0 and maybe like 20 times before it finds a location. And then once it finds a location, which will happen instantaneously, by the way, then it'll start applying force to that location. So as you're looking at it from a gameplay perspective, it'll just look like it's roaming around. But really what it's doing is it's testing like 1,000 different locations like every time it tries to pick a spot. But anyway, that'll make sense in a sec. So let's do this box trace. So the starting point, we'll say get actor location. The end point will be our new provisional roam location, which what we might do is we might promote that to a variable actually. Provisional roam location. And we don't want to make that public because we're not toggling that at all. This is just a completely internal variable. So that can go there like that. So that's provisional roam location, which we might actually just drag over a little bit. Oopsie daisies. And then if we drag that in here and set that to the end point like that, now what we need to do is we need to set up a half size for the box. So if we grab our controlled pawn reference and we say get bounds, I think. So we have a box extent, which I'm not sure if that's... Oh, we want that to be only colliding components, by the way, because otherwise it'll include like other weird shit that you might have hanging off your actor, like overlap volumes and stuff. The box extent, I think that's the half size, so we can just plug that straight in. We'll test that in a sec anyway, and if it's not, we might need to divide it by 2. Now the trace channel is visibility, actors to ignore. We'll say make array, and we definitely need to ignore ourselves, which I think is already an option there, so that's fine. And the debug type, let's just promote that to a variable actually, just so we can have access to this from outside of the actual logic. So let's just tick that there like that. And if we go into our task here, into our behavior tree, sorry, and we type in, what was it, find valid flying location. So now you can see we've got access to these variables here. So min distance 500, max distance 1000, debug type, let's set that to duration for now. So we could find a location and then let's just wait for 5 seconds and then try and find another location. I think that'll be okay for now. So let's just add a finish execute node. Not because this task is done, but just because we want to test that it's working. So let's jump in and let's just see what this does. Okay, so see that? That's its box trace. That would have been the location that it would have tried to move to, and now it's just trying to move there. And now it's going over there. I just want to see that it goes behind it, because maybe it's only getting positive values. So let's just give that a sec and see if it does one behind it. There we go, so that's one behind. And you can see that it's red, which means it's not colliding with anything either, so that's really good. But if I were to like jump up and it were to try and move to me, which it probably won't. So let's just move on. So that's working. So that's the test to see if this is a valid location. So they would have returned as valid locations. So let's just get rid of that finish execute. I'm just going to take a drink for a sec. Tap the right key to fast forward if you like. So now I guess what we want to do to determine if it's a valid location is we'll just add a branch. If there was a hit, then let's actually promote this to a function. Sorry, so let's collapse it to a function, and we'll call this test provisional flying location. And yeah, I guess that can just be like that, it's fine. Probably didn't need to collapse it, but whatever. So I guess really all we need to do is just test if there's a hit. So we could just add a return node there like that. And that could just go straight into that, and if there is a hit, then it's not valid. So let's just put a not boolean there like that, and then just plug that into there, and just type in valid location question mark. So if there's a hit, then it's not a valid location. If there's not a hit, then it is a valid location. Okay, this is a bit clumsy. Like, I probably didn't need to collapse that to a function, but whatever, we can just roll with that now. So we can just have that like this. Now what we can do, if it is a valid location, we'll continue. If it's not a valid location, we need to go back and we need to do this again, but we don't want to just go straight back. What we want to do is we want to add a counter in here, so that if it really can't get a valid location at all, we don't want it to go into an infinite loop and then crash the game. So let's just add a variable in here and then just call this counter, and we'll make that of type integer. And what we can do down here, if it doesn't work, we can just say increment integer. The default of this will be 0, by the way, so when this starts, it'll be set to 0. If it fails, we'll increment it, and then we'll just have a branch down like that, and we'll just check that the counter is less than or equal to some number, which we might make like 25, so it'll only ever try 25 times. Now if it is less than 25, then what we're going to do is we're going to go back to this here. So that's a bit messy, but if I tidy it up a little bit, it makes a little bit more sense. So it'll look like that. That's what we're going for. If the counter is greater than 25, so that means this is run 25 times, it's got a new location 25 times, and it's tested all of them and none of them are valid, then we're going to have our finish execute node, but we're going to mark it as a fail. So we could just have that run into there like that, and this one up here will be a success though. But before we mark that as a success, what we need to do is we need to add a blackboard key, which can be move to location key. So this is going to output the vector that we just got as a blackboard key, so that we can use it in the next tasks. So let's make that public and drag that in, and then just say set as vector. This is getting a little bit muddled, but let's maybe just drag those down like that. Drag that down so it's nice and neat. And then the value here can be the provisional roam location. And then we mark that as a success. So if I just run through everything that's just happened, get a random location on the X and Y at the same height that we're at right now. Test if that location is valid with a box trace. If it is valid, then set the blackboard key as that location and then finish the task. And now, so this move to location here, if you set that to the move to location, we can have the next task here use that move to location and then move to it. And we can disable this. Oh no, let's leave the debug there for now. Now if this returns false, then we count. We check if the count is less than 25. If it is, then we go back and we try and get another one. If it's tried 25 times and it still is failing, then we're going to mark it as a fail. And then what will happen is, instead of executing the next thing in this sequence, this whole sequence here will fail. And then it'll go back up. Oh, sorry. If this fails, then it'll just wait. The selector will pick the next thing to its right, and it'll wait. And then it'll try again. But what we could do is we could have a selector node down here. And so instead of just waiting if this returns bad or like doesn't work, we could have a teleport thing here. And what we could do is we could teleport back to our origin, and we could look at our target. So we set that up in a previous tutorial. I think it was called like smart teleport using EQS or something like that. But if that didn't make sense, like what that means, like don't really worry about it. Actually, you know what? Maybe we can just delete that for now. But that's what you could do if you had a teleport thing. So like if you had your enemy spawning in a correct location with a lot of open space, and you always knew that where it started it was always going to have somewhere to go, then if for some reason it didn't have anywhere to go, it tried 25 times and it couldn't get anywhere, which means it would have flown into an awkward spot, then what you can do is, if this fails, you can have a select node and then you can have it teleport back to its origin and be able to move again. So you can stop it from getting stuck and just like perpetually waiting because this keeps failing. Okay, but anyway, let's just go on to the next task. So new task, behavior tree, thingamabob, F2, and this is going to be called add force to location for flying AI. Bit clumsy, but you know, whatever. And we can probably close down this other task now, because that's done. We can close down our AI controller, and probably even our AI BP, to be honest. Why is that all highlighted and shit? Alright, that's done. Okay, let's just check that I covered everything in that last bit. Oh yeah, so I did have that teleport to origin bit there, so that's all good. We can cross that out. Now add force to location. Alright, let's build that. Fuck, this is going to be a long tutorial. We're already 25 minutes in. I hope you guys don't mind. Hope you're learning a lot. To be honest, I like the long tutorials because I think it's cool to see how people do things, like, you know, like generally over a long period of time, rather than like something they've just prepared for a 10-minute tutorial, which isn't always like an accurate representation of how they work. And I think you tend to pick up a lot of neat little tricks when you watch someone do something for ages. Okay, so now we're adding the force to that location that we've just got. So the first thing that we'll do is we'll promote this to a variable, which will be controlled pawn ref. Hopefully I can make it through this in one take. Last time I had to break it into a couple because I started getting too tired. So now that we've got that, I guess we just want to... We could set a timer by function, probably. Let's say set timer by event. And the event we can just have down here, custom event, which can just be called add force. Hook that up to there. The reason that we're doing this is because we're going to add a little bit of force every frame. I wonder if we should even do this with force. Maybe we should just do this with velocity. Yeah, let's try it with force. Let's just see what happens. So the time will be the world delta seconds. Looping, yes. And then we're going to promote this to a variable, which is going to be called force timer ref. Okay, so when this receives its execute, we're going to be setting a time which is going to be adding force towards some location. So let's say add force down here now, which we cannot do because we need to have a thing down here. So let's say add force. Add frost. I like writing frost for some reason. Okay, and that doesn't want to work either. Force. We don't seem to have access to a force node. Well, what if I just type in force and then untick context sensitive? Add force. There we go. We got that there. Target is primitive component. Okay, so what we might need to do is we might need to get the capsule component for this guy. So this is just a pawn reference. So let's say cast to character. Now, what I might do actually is instead of putting that there so that's being used every frame, let's just put this up here and set this up in the beginning. So we could go like that, and we could then promote this to a variable here, tick context sensitive, and this can be called controlled character ref, and that's of type character. Now what we might need to do is if the cast failed, let's just have a print string up here, and then let's say add force to location BTT task failed because controlled pawn wasn't a character. So this is important now because what we're doing by using this cast to character is we're saying that this task can only work with blueprints that inherit from the character class, which is fine because, well, we need to do this because we need a reference to the capsule, which we can only get if we cast to a character, because character blueprints have a capsule. All of them have a capsule. So whenever you're going to add this logic to a AI, make sure that it's a character AI. So now that we have a controlled character ref, we should be able to say get capsule. Right down the bottom, get capsule component. And now, is that a primitive? That is a primitive, okay. And now the force that we're going to be applying, we might actually just tick acceleration change there as well, because you want this to work the same, like, what do you call it, like, regardless of the mass or like the size of the actor that's being, or the character that's being pushed. If you make it without acceleration change, it just adds another variable into the situation, the mass, and it just makes it a lot more complicated to get things moving smoothly. So let's just say that's acceleration change for now. Now the force that we're going to be adding, this is going to be dependent on the distance between the character and how much further they've got to go to the location. So what we could do is we could have a lerp here, and a lerp will use value A when alpha is 0 and value B when alpha is 1. So we could determine an alpha from the distance between us and the final point. The velocity at the final point can be 0, and the velocity beginning can be the max velocity that we're allowed to have, or the max force that we're allowed to have. That was a mouthful, but let's just build it and we'll just see how we go. So let's just create a new variable in here which is called target location key, and this is going to be of Blackboard key selector. That needs to be public because we want to be able to edit that in the behavior tree, and this is also going to be a thing that we're going to set up at the start here. So target location key, let's say get as vector, and then I'm going to promote that to a variable and call this target, let's call it move to location. Actually no, we should probably keep them named the same. Let's call this move to location key rather than target key, because we're using target back in the behavior tree to refer to the actual player. So this can be moved to location. And that doesn't need to be public because we're not going to be editing that. So now we can plug that into there, just like that, and now that's all set up, and now we have a target that we're moving to. So how the hell am I going to convert this to a between 0 and 1? Let's say get distance. Let's drag in our controlled pawn reference, or the controlled character, it doesn't matter, and say get distance to. Now, no, that's not going to work because that takes in another actor. So what we're going to need to do is we're going to say get actor location, and then what we're going to do is we're going to say minus vector, and we're going to minus off the move to location, and then that'll give us a vector from the move to location to the location of the controlled pawn. And then what we could do is we could get the length of that, we could get the length of that like that. Okay, so I've got an idea. So this here is returning the length between the controlled pawn and the move to location. So what we could do is we could save the length at the start there, and then what we could do is we could get the length every frame and then check the result of dividing the length at the start, or dividing the length of where we are now by the length of the start, and that'll get us a value between 0 and 1, or something along those lines. It works in my head, and I've got a feeling I can make this work. So let's just roll, and I'll explain it as we go. So I'm going to collapse this to a function and just call this get distance to final position. Fucking hell, I got a feeling this is going to be a little bit of a back and forward, but hopefully that makes sense what we're doing here. I'm not going to explain it again. I explained it earlier, so let's just keep rolling. And we're going to make that a pure, because it doesn't need an execution pin. And let's just say return node, and then just plug that in there. And then this is just going to be called distance. I might need to take a break soon, to be honest. I don't know if my brain's going to be able to handle this. Just going to take a sip. Hang on. I'm not used to talking this much, hey. This is unusual for me. Even though I've been doing these fucking tutorials for ages now. Okay, so we can promote that to a variable and call this initial distance. Dist nice. D nice. Okay, and then that can go in there. Now let me just move all that over. So what we're going to do now is to determine this alpha is we'll get we'll grab in the initial distance, I think what we want to do is we want to say the current distance, we want to say the initial distance, so let's just say that's like, I don't know, like 1,000 minus the current distance, which for example halfway through moving might be 500, so that's half, which will return a value of 0.5, and then we can say a div float down here of the initial distance, like that, and then that can go into the alpha. So let me just explain that again, because I got a feeling my brain just kind of turned off because I was still thinking while I was speaking and my words weren't coming out properly. So if we go the initial distance, so for example, if this is 1,000 and this is 500, this will return a value of 500. 500 divided by 1,000 is 0.5, which returns a value of 0.5 there, which is halfway between A and B, so it'll apply half force. Now, if this were say 100 and this were 1,000, this would return a value of 900, and then this would return a value of 0.9, which would be mostly B. So if the distance between us and the final location is only 100, then you want to apply less force, so 0 velocity. So as we get closer to, as this approaches this, so the final location approaches the distance to the final position value approaches the initial distance value, we're going to apply less and less velocity because this will be closer to 1. But if it's the other way and we're max distance away, we're going to apply enormous velocity. So what we could do here is we want to say unit direction vector. The direction that we're going to be applying the force in is going to be from our controlled character or the controlled pawn, it doesn't matter. Get actor location. We're going to be applying from our location to the move to location. Except, actually no, that's fine, we can just have that like that. But then what we need to do off of here, so this is returning the direction, and then what we want to do is we want to say multiplied by float, and then we want to plug that into there, and this is going to be max force magnitude. And we could make that public there, although rather than editing that, so let me just add that in here. So this is what add force to location for flying AI. Rather than setting that here individually for different AI, what we could do is we could actually we could create a component that could store this variable, and then we could have this up here load that component for the specific AI, which in this case is our flying AI BP, and then use that. But I'll explain that later. Let's just use this for now, and let's just set this force magnitude to, I literally do not have a good idea for what would be a good magnitude. Let's just try like 10,000. That might be way too much, I've got no idea, or it might not be enough. We could do this with velocity as well, like instead of saying add force, we could just say set velocity, which to be honest might be easier. But anyway, let's just roll with that. And now what we want to do is every frame this is running, so let's just have a branch down here, and then I guess we could just use our get distance to final position and just check if this is 0. So let's just say equal or less. Is this less than or equal to, well, maybe we shouldn't go 0, maybe let's just say like 50 or something. So we're just checking, this is just checking if we're at the target location. And if we are, then I guess what we can do is we can stop this force timer and we can mark this as a success. So we could just say here, we could say clear and invalidate timer by handle. And if false, then do nothing, because this is just going to rerun again next frame and it's going to do the same thing again. Okay, so that should be all good. So let's just off here, we'll say finish, execute, mark that as a success. And what we could do, I guess, is in the case that this is constantly firing and never actually gets to the end, this will never actually succeed. So what we could do is we could have a thing off of here, so we could have like a delay, and we could promote this to a variable and call this max time allowed until auto fail. And we could make that public, and let's just say we'll give him like, I don't know, 10 seconds to get to his location, and if he doesn't, then we'll just mark it as a fail because something's obviously blocking his path. And if that happens, then we say finish execute, fail. So we leave that like that. And let's just comment all of this off, to be honest, because this is getting a little bit messy. So all of this here, that's all just set up. So hit C and then type in setup. this here, begin adding force, and then this here is add force towards target location. This is the crux of the flying AI, by the way, is once you've got the valid point, this is how you move to any location that you want in the world. Now you can obviously get this, you can make this more complicated by like using like pathfinding. Like for example, is say there's a blocking object in the way and you want to get from here around that object, is you could get it to survey a bunch of points and then find a path around the object to get to the one that you want to go to. But I think that's out of the scope for this tutorial. I might do one of those like way off in the future, but not today. This right now is basically just saying get a point that we can see. If there's a clear path from us to the point, then let's just fly to it. And then you can use that whichever way you want. You could use it to chase people, you could use it to, like, I don't know, patrol around or like whatever. Now this here is just saying, this is just check if completed, I guess. So we can just comment that and say check if completed. And this here can be auto fail after time t. Okay, let's just check that we've set all of these. So the move to location, that's set in the blackboard in the behavior tree. The max force is whatever, we might need to fine tune that, and then the max time allowed until auto completion is 10. Okay, now I've got a feeling this will need to be simulating physics in order to add force. So let's just run and let's just see what happens. Okay, so it found a spot, but it's not doing anything, and I'm probably going to get an error, which will say simulate physics needs to be enabled. Okay. So go back into your flying AI, go to your capsule component, and just type in physics. Simulate physics, set that to true. Actually, maybe let's just scroll down. Yeah, simulate physics needs to be set to true. Now you can tweak these parameters here, which we might play with a little bit later. So let's just try this now and see what happens. Oh, look at that, he's moving. But see, he shot straight through that, because now his task succeeded. Now what's he doing? I guess he's just oscillating back and forwards. Jesus Christ. That's sort of like mesmerizing, isn't it? So I think what we might need to do is we might need to crank up his values here. So I might just like set that to like 10 and set this to like 10 as well. That could be like way too big, but let's just see what happens. Okay, so now he's moving really slowly. So maybe 10 was a bit too big. You'll just need to play with these, I guess, and just to figure out what will actually work. Am I in the right thing? Flying AI BP? Yeah, here. Maybe 1. You don't want it to rotate, so I've made that really big. But the linear force, you can let that be alright. That looks pretty good, except he's gone past. He's gone past the point. Which I guess is okay. Let's just go back into his task. And before this finishes the execute, let's just have a print string that says reached location. And I might just make that green so it stands out a bit against the blue sky, and then just have that for 10 seconds. Okay. Okay, so now he's stopped, and if we go to his behavior tree, he's waiting, and now he's gone for another point. Except this time he went a lot faster. Huh. Alright, I'm going to take a little bit of a break and I'll come back and I'll tidy this up. So, BRB. Okay, so I did some fiddling and I found out a few things that we needed to fix up. So, one thing, add a little weight node in front of this here, just like that, and just change that to like 0.1 or a really small time. This is just for now. The reason that you need that is because when we're using this add force location thing and we're using our world delta seconds, if this is called on the very first frame, I just realized that we probably don't want to use that there actually. So what was going on is something that I noticed is that the forces were inconsistent. So like the first time he moved much slower than every other time he moved to his location, and that was because of world delta seconds. The frame rate at the beginning of the game was different to what it was later, like right at the beginning of play. So actually let's just get rid of that completely and let's just set this here to I don't know, 0.01, so like 100 frames per second or something, just so that it's consistent and it's going to be adding consistent forces. That's an annoying thing about this add force thing, to be honest, is that it kind of depends on the frames and things get weird. And anyway, so now we should be able to get rid of that, so let's just see how that works. Before I hit play, something else that I changed was this max force magnitude. I changed that, so let's just set that to, maybe let's try like 5,000 for now, and let's just see what happens. I think that was all I changed. Yeah, okay, so I'm just going to hit Control Shift S to save everything, and then hit play. Oh, something else I changed, sorry. Flying AI in here, linear damping I've set to 5. Just to add a drag to reduce the linear movement so that he stops at his point and doesn't overshoot it. So there, just like that. That's what he's doing now. So now he'll wait for 5 seconds, and then he moves to his next point, and he's reached his location. He's waiting. He's not quite in the center of that box where he was meant to be. He's overshooting just a little bit. So I guess you could tweak this a little bit and maybe make that like 7. Make it a little bit more. This will make him move slower, but it'll make it more accurate. So there you go. He's right at his point now. Oh, he's even a little bit before, because we had a what was it, a value of 50 as the tolerance. So just like that. And if you wanted him to move faster, you could increase that or decrease it or whatever. So you can play with all kinds of parameters. And what we might do towards the end of this video is we might set up a component that we can add in here like that, that'll automatically load all these different parameters, so you can set them all in one place. So like, for example, we'll load these dampening factors, we'll load this max force magnitude, and etc. We might also add a max velocity thing in here as well. You know what we could do actually, is what might be a better way to do this is, instead of this being max force magnitude, which is what used here, that could be like, I guess that could be the acceleration. So we're adding force there, and then what we could do is we could have a, yes, let's do this. So let's have this, let's rename this to acceleration. And then what we might do is we'll add a branch in here. And I might just collapse this to a function, just so that it's neater, and just call this get force vector, and make that a pure function, and then just jump in here and just check that that's all good. I think that's all good. So we can close that, and that can be get force vector just like that. And just before we add the force, what we could do is we could just check that our controlled character ref, we can get our velocity or physics velocity of the capsule component, get physics linear velocity of the capsule component. Maybe we'll put that up here like that, and get the length of that. Sorry, get vector length, and just check, is this less or equal to a variable that we'll have as max velocity. So now what we could do is we could have him, using the force vector, we had a acceleration value, so we could have him accelerate really, really quick, but then not move above a certain velocity. So that's just another way that we can get more control over what our dude does. So maybe we can collapse this here just to a function, which I might just call below max velocity question mark, and that can not be a pure, that just needs to be normal like that. And this here is going to be, so is the vector length less than the max? So if this returns true, this is below max question mark. Compile, save, close that. And now if we are below max, add force. If we're not below max, let's just go straight over here, we'll skip the add force. So that'll get you a nice consistent speed. If you wanted your guy to move at a consistent speed, you could add the acceleration right up, so like something really, really high, and then have a max velocity of whatever speed you wanted him to move at. So make that a public variable for now, and maybe like 2,000, maybe 1,000 would be good. And let's just see what that does. Where's our AI? There he is, up there in the sky. And to test that that's working, we could actually go back into our add force thing, and we could just have a print string down here. And you know what? We could even add a branch and have a variable and just call display debugging ? Debugging. If that's false, just skip the print string and just double click to add those reroute nodes just there, and this can be reached max v, just so that you can display these messages if you want, so you can understand what's going on. And I might just add that, make that red, and just, yeah, it can be there for 2 seconds, that's fine. Okay, that can be public variable. So now that we have access to that here, like that, default should be no though, so we'll set that default to no. And now on here, let's just have that set to yes for now. So now, so he's reaching his max velocity, you can see. So that means he is accelerated to whatever speed we set, which I think was like 2,000. Okay, he didn't do it that time. That was interesting. Maybe that was a shorter distance than last time, because he's getting distances between 500 and 1,000, so some distances will be less than others. I'm kind of curious to see if he reaches his max V again. Let's just lower his max velocity, because I want to see that he's reaching it, and that not something is not going wrong right when we begin. So maybe let's set that to 250. Because he only did it on the very first one, which makes me skeptical. Okay, so he's reached his max velocity, he's moving at 250, he's reached his location, now he's waiting for 5 seconds. I should shorten that. Okay, so now he's moving at 250 again. There we go, that's working really well actually. And obviously this is like a very boring flying AI movement. But what you could do is you could have an AI with a really high do we have a tolerance here? No, we didn't have a tolerance. Let's go back into our flying AI add force to location thing. So this here, check if completed, distance to the final position. So let's call this distance to position before success. Well, let's just call it tolerance, honestly. That makes sense. Let's just call that tolerance and make that public. So right now that's 50, but say if you wanted an AI that really floated around really smoothly and sort of drifted back and forwards rather than going directly to a location, you could have a really high tolerance, and you could have a slow acceleration. You could have a slow acceleration, whatever for your max velocity, and then in here you could have a low linear damping. So he'd sort of fly to a point, he'd drift past it because he had a low linear damping, and then he'd start to turn to the next point already. So you'd also have a low time here, or maybe that could even be instant. So he'd be curving through the sky from point to point rather than just directly going straight towards them. But I'll show you how to set that up later, and we'll create a component to put everything in one spot so that you can play with them easily. So that's good. I'm just gonna put this max V thing off for now so that we don't get that message anymore. And one thing that we're going to do is just in here, you would have seen that he was moving towards one location, but his rotation is facing one way. Let's just make him face the way that he's going, and maybe we can make that a variable as well, so that if you had a spaceship with no direct front, he wouldn't rotate, but for something like a cone you want it to rotate. So let's just set that up now. While we're adding force, before we check if we're completed, this is where it'll go. It'll go right in here. So we can drag this across, and that's going to move the reroute node, which we don't want. So let's just move that across like that. Oh boy, oh boy. Check if completed. Okay. So what I might do is I might just even make this a function. So this can be called update rotation. Oops. Update rotation to face velocity. And the way that we'll do that is we'll have a branch here. So this is back in the task event graph, and this can be update rotation to face direction. Compile, save, make that public, default to yes. Now, if that's true, what we're going to do is we're going to drag in our update thingamabob function, and this will be called every frame from this event. If it's false, add a reroute node, and just plug that up there like that, double click here, and then just put that in there like that. And then we can bring all this back just there, and this can be commented and called update rotation question mark. And just give that a little bit more space. So now if I go into here, is my voice actually recording? Yep, it is, okay. So let's grab our, it doesn't matter, let's just grab our control character ref. You could probably get your porn reference as well. And just say update, oh no, sorry, we don't want to say update, we want to say set rotation. Set actor rotation. And the new rotation will just be alert, so we'll get some value between whatever and whatever. The alpha can be, I don't know, 0.5, shortest path, yes. The initial value for A is going to be our current rotation, so we can copy and paste our control character reference and say get rotation, get actor rotation. So we're going to be lerping between our current location and the current rotation and the rotation required to face the point that we're moving towards. So we'll get our move to location, which is the one that we're moving towards, and we'll say get unit direction vector from our location. So get location of us towards, so the unit direction vector is from us towards the move to location. And now we need to convert that to a rotator. Is that easy? I wonder. Oh, maybe I should use look at rotation. That would be much easier. So let's try find look at rotation. Yeah, that's what we want. The start is the location of us, and then the target is the endpoint like that. And that should be good. Now you can play with this alpha, and to be honest, maybe we'll promote this to a variable. So this can be called rotation alpha. Alpha. Whatever. Public, so we can edit that later, and we don't have to keep coming back into this function to see what's going on. If you wanted to, you could untick shortest path to make him do like retarded turns, like back to front and stuff. That could be kind of cool. But let's just see if this works. There we go. He's facing his point, and then we wait 5 seconds, and I'm actually just going to shorten this to 1 second. Alright, he's moving to his point, he's reached his max velocity, reached his point, waiting 1 second, and then he's rotated and he's moved like that. Now that was a little bit too quick for me, so I'm just going to go back into here, and the rotation alpha I'm going to change to 0.1. Because it looks like he just snapped straight to the way. I want him to kind of like smoothly rotate. Yeah, that's good, look at that. Wait a second. Boom. That's dope. Oh, and see, he just collided with us, and that was really lucky. So he didn't move to that point because I would have blocked his path. So he picked another path. Oh, that's really cool. Man. This is exciting. I love it when this shit actually comes together. God, just never gets old. Now what? That might even be like everything that we needed to do, pretty much. That's like the basics. So this add forcing, it's so funny because I had just like 3 dot points there, and that was like that whole thing, the last like 30 minutes. 3 dot points took 30 minutes to do, probably even more. Okay, so let's save all these parameters in a single place. So if like you could work with this how it is, and you could ditch this tutorial right now and go build your own flying AI. Everything that I'm going to do from now on is just kind of making it a little bit easier to use. Like this fly to random location above player. This is literally no more new logic, pretty much. It's just what I'm going to do for that is I'm just going to find a location above the player rather than relative to us, and then we're just going to use the same node to fly there, and that's literally it. Like that's pretty simple. And then the patrolling system is just the same thing. It's just get the location from a patrol point that you've placed in the world rather than a random location and then just move to that. So these two, like the logic is already built for those two. It's just a matter of putting behaviors for them into the behavior tree. Now this thing here, this is a little bit tricky, so let's just do that now. Save all the flight parameters together. So this will just make it a lot easier for you to edit all of this stuff. So let's go into our content browser and let's add a new blueprint class, and it can be actor component. I don't think it needs to be a scene component. Let's say actor component, and then let's call this physics move to parameters. Now inside of this is where we're going to store stuff for the task. Well, actually, should we use this? Yeah, we should. Okay, so let's just add a custom event, which will be called setup, and we're going to need a reference to our controlled pawn. Actually, no, we won't need that because we can just use the owner node. So let me just delete that. Let's say get owner, and then we could say cast to character, because this is only ever going to be used by a character. That's very important, because we use the capsule to add the force to in this function, so this can only be used by characters. So I might just grab this here and then just paste that there. So that's just our error node. Control pawn wasn't a character. Now let's get a reference to our character. We might as well just save that. Owning character ref. Now what we're going to do here is we might also grab this capsule. So let's just grab the capsule component. Oh, actually, no, I probably won't need that, honestly. Or maybe I will. Get physics, angular damping, etc. Is that... Get angular damping, mesh cap... Okay, so we do need the capsule component. So let's say get capsule component. And then let's promote that to a variable as well, because this is the thing that's the force is being applied to. So let's call this physics capsule. Physics capsule ref for reference. Now, things that we want to do in this component to make sure that this runs smoothly is we'll need to grab that, set simulate physics to true. So you know how before in here we set a bunch of shit in here, like we set simulate physics to true and the linear damping to true and the angular damping and the gravity and etc, etc. You can set all of that automatically in the script here. So then what happens is when you add this component to a new AI, you won't need to go through and redo all of this again. It'll all just be in the component. So we'll set simulate physics to true, enable gravity to false. If we get our character movement, we want to set the gravity for that to false. So get character movement. This is just basically to save you time when you're building a lot of different AI. So set gravity scale to 0. Now we're also going to need to grab our capsule reference and what was it, linear damping, set linear damping. So let's promote that to a variable. And what was the value that worked well for us before? The value that worked well was 7 for the linear damping and 10 for the angular damping. We didn't really test the angular damping, but let's just roll with that. So 7 for the linear damping, and then we'll set the angular damping. And that we'll promote that to a variable and call that angular damping. And we'll just make that 10. And now those two can be, we'll make those public, or actually what would be even better is let's just call this toggleable and then put both of those into there. Okay, now I think that's everything that we needed to set for the blueprint. Gravity, physics, and the damping. Okay, so that should be all good. Now what we want to do is in this flying force thing, in this one here, this used a bunch of stuff like acceleration, max velocity, tolerance, and rotation. So instead of having these set in here, so I'll leave them ticked for now, just so I know which ones I need to do. Actually, no, let's untick them. So we'll untick acceleration, untick, or make public max velocity, tolerance, and rotation alpha. And then let's compile and save. And what we're going to do is we're going to add a little thing in here which loads all of those variables. Instead of loading them from here on the behavior tree, we're going to get them to load from this component that we just made, so that we can edit them here rather than in the behavior tree. Because sometimes what you'd like to do is, if you were to create different children of this flying AI, say with like different levels, like maybe you got 5 levels of difficulty and they all run the same behavior tree, you can use the same behavior tree asset, but then just literally go into here and then just tweak the variables. So what we could do is, when we add our physics move to parameters, sorry, my speakers are just going retarded for a sec. So physics move to parameters, we just click on that, and then all the variables are here. So if we have children of this, all we need to do is just toggle everything in here rather than make a different behavior tree for every single one. So this is just personally what I do, because it saves me a fuckload of time, and it makes it really easy to make like different colored enemies and like different like movement parameters and things like that. Like you just create children and then they're all good to go. So where I will load all of those parameters is I might just drag this across like that. And you know what, maybe I might just even put it into a function. So this can just be called set all load and set movement parameters. Oh my god, my speaker. I might just turn... No, maybe I won't turn that off, just in case it fucks with my recording or something. From component. So I'm just going to put that right there. "22 minutes, we're doing alright. Oops. Okay, so inside of that, let me just compile and save for a second. Have I got any more water? I'm gonna have a sip. Hold on. So, grab Control, or maybe Alt, I think, and drag in your acceleration. Yeah, Alt. Drag in your acceleration, drag your max velocity, drag in your tolerance, and drag in your rotation alpha. And then what we want to do is, let's just move all those across for a sec. We're going to get our controlled character reference, or the controlled pawn, it doesn't matter, and say get component by class. And the class that we're going to be getting is our physics move to parameters, and then just check, is that valid? If it's not valid, print string. By the way, you could make all of this a function. That would be like reusable in a function library, which would save you doing this, because we've done this a ton of times in the previous tutorials. But if you haven't followed this in the previous tutorial, I'll show you what we've done in the previous tutorials. Get component if valid. We built this function here, where it takes in an owner, which is this, the component class, which is that, checks if it's valid, and then gives a reference to the component. So if you look inside, it's got this thing here, and it's got an automatic error message if they don't have the component, with a ton of spelling mistakes, the compulsory spelling mistakes. So, but if you don't have that set up, this is how you do it. But it's good to have that set up in case you're using components all the time. It'll just, yeah, save you time. So, this is didn't have physics move to class, with a ton of spelling mistakes. Fantastic. Perfect. So now let's just, we could probably have a, let's make that variable. So we'll go call this physics move to component ref. So if that's valid, we promote that to that there. And then what we want to do is we want to go over here and, oh, what the flip did I just do? Uh-oh. Uh-oh. There? Yes, got it. Okay. No, where was I? So if we go into our physics move to parameters here, we're just going to create a ton of new variables in this category, which I don't think you can do. So let's just call this comp underscore acceleration, and we'll make that a float. I'm calling it comp because I want it to be differentiated from the variables in here, which I've just called acceleration. So this is comp acceleration. And I might just drag that in there and then make that public. I think now if I duplicate it by hitting Control W, we'll get comp underscore tolerance, tolerance, Control W, whoops, click Control W, comp underscore max velocity, and then comp underscore, what was the last one? I don't remember. Max velocity tolerance rotation alpha. So comp underscore rotation alpha. Okay, so now that these are in here, let's set these to the values that we had previously so that they're the same. So 5,000, 250, 50, and 0.1. There's no way I'm going to remember that, but let's try. 5,000, 50 for the tolerance, 250 for the max velocity, I think they were in reverse order, and then 0.1 for the alpha. So now if we go back into here, which is our behavior tree task, the add force one, we can say get comp get acceleration. God, that's bloody dyslexia or something. Get comp max velocity, get tolerance, sounds like a disease, and then get the alpha. So now what's happening in here is none of these variables in here are actually being set from the behavior tree, and the defaults aren't even being used. So we could reset them to 0 if we wanted. All of those variables are getting loaded from this physics move to thing. So they're all getting loaded from here. And the benefit of doing that is now that I can go into here and just tick this, everything there is in one place. So I can easily play with that for this AI, and then I could like duplicate it and then have it different for a different AI, and etc. And then like if you were to make a child like this, flying AI child, you could just go in here, and instead of having to duplicate his behavior tree, boom, you can just toggle this. So we can make this guy's linear damping, I don't know, like 1. His acceleration could be 10,000, so he accelerates really quick. Maybe his max velocity can be 500, that's fine. The tolerance, let's make that really big, and his rotation alpha can be like really slow. And let's say we wanted to make this guy a different material, so we could make him like slightly blue like that. And now if I were to, so that's the white one there, and now this one's the blue one. So see that guy around the back, he's moving a lot faster because we gave him different parameters. I think I made his, yeah, look, yeah, it's cool. I want to make him like move around really smoothly. What if I were to just delete that weight node just there? So we got a new location instantly, and maybe I might even make his linear damping even less, so 0.1 even. Let's just try 0.1 and see what happens. So he'll move really quickly now, and he'll probably just fucking like fly all over the shop. Yeah, look at that. So I might just also disable that ugly box. So if you go to your find location, you can reset that to none. Now we can watch him flying around. Look at that. Look at him go. And they won't collide with each other because they'll be able to tell like if they're blocking each other's path. That's really cool. And this guy looks really smooth because he had a really low alpha. Look at how he turns around. And just to show you what would happen if you were to, in this task, the physics move to task, you could also have a variable for this shortest path thing. So actually, let me just check that works. So what if I just untick that? Now they'll start turning all funny and it'll look really weird. See how he's like, it's like if you've ever seen Zoolander, how he can't turn left. Like it looks like he should turn one way, but he turns another way. It's probably hard to see, but it's just really like unintuitive and like weird. Which would be cool in a game if he was looking for the player, because he'd like turn around the wrong way every now and again and kind of like spook you a bit. But let's just leave that. No, let's make it a variable. Fuck it. Shortest path. Just like that. And the default will just have it set to yes. So now this behavior tree will use yes, but if you wanted to make a weird version, you can just duplicate the behavior tree and make that no. Okay. So that's it for that. That's basically the flying AI. Like, let's be real, that's pretty much everything. The only thing that I was going to do was create like a task to get him to like follow the player. Which I don't think I'm gonna. I'm probably just gonna leave things here for now because I think this covers like the basics. So maybe I'll do it in another tutorial if you feel like you need it. Leave me a comment. But basically, what I was gonna cover was, so this is all the flight parameters are all set and saved and everything. So if you wanted it to chase the player when he saw the player, for example, what you'd do is you'd add another behavior here, which would be a sequence. So this is the roaming sequence. This one here would be called chase sequence, and for this one you just have a new task. So we'll create a new task like that. Let me just dock that, and you'd call this get flying location above player, BTT. And I can't be bothered setting that up right now, so I'm just going to leave that as rec execute and finish execute. But in between, what you do is you'd have it get a location above the player, just like we did with this one here. So this is just getting this new provisional roam location. It was getting it relative to us. So all you do is you just make it get it relative to the player, which honestly, maybe what we could do. What if we had here actor to get location near key, and then we could change that to a blackboard key selector, make that public, and then we could say get as actor, and then we could say get actor location. Oops, sorry, that was already get actor location, but that can just go in there like that now. And so then what we could do is, if we go into our flying AI here and actor to get location near, what we had it set to was self actor because we were getting our own location. So if I were to run this now, let me just detach that, they should behave just like they did before, flying around randomly. But if I were to go in here now and say set the target as the actor to get the location here, they should just start flying around me. And at my height as well. So if you wanted them to fly above the player, what you could do here is you could break that, make a vector there. You can add the X and Y to be the same, and then what you could do is actually what I might do is I might just say this add float, and this can just be called added elevation, without a question mark. So that can be default to 0 if you want no elevation added to that get actor location. But if you wanted to, so if you would say chasing the target, let's just make sure that that's set to 0 as the default. If you wanted to be chasing the target at a particular height, you'd just go into here and you'd say you want the elevation to be 1000, and now they'll do exactly what they did before, but 1000 units above my head. That's maybe a bit too high for you to see, so maybe let's just say 300 units above the center of the character, sorry, not above my head. There we go, so now they're flying towards me and they're staying 300 units above my head, constantly roaming around. You can't see them because they're a bit tricky, but yeah, and they'll just follow you. That other guy's a bit slow because we had his max velocity really low and his acceleration really low, but the blue one, he was flying around. So cool, that's how you do that. So honestly, we could probably just close that there and get this location above the player. We could probably just delete, we don't even need that. We could just use the same task here. So this one here for the roaming sequence, you'd have that with self actor as the origin without an elevation, and then for chasing the player you just plug that in like that and call this chasing sequence, and you just add a decorator here, blackboard decorator, which would say we want to abort both on result change, and we're just going to say can see target needs to be set. And the can see target is set from the pawn sensing that we set up in a previous tutorial. either the custom pawn sensing that we built or the AIC pawn sensing. So in the AIC pawn sensing, it's doing this every like 0.5 seconds, and it's updating the can see target variable when it can see the target. So when that's set to true, we'll move to a location near the target with an elevation of 300, and then fly to that location just like that. And then when you can't see the target, this will abort and it'll go back to this. Simple as that. What we should do actually is, if we go into here, we might need to set up an abort thing. So I might just comment this really quick. So this is finding the valid locations. That's fine actually. So that's setting up, that's getting the location, and then this is checking. That's checking if it's valid, and then this is just re-looping. If I go back to, where was it? Flying AI. Add force to location. If this receives an abort, we want to stop this timer. So let's go up here. Receive abort AI. So for example, the reason that it might receive an abort, so if it's moving to a location here and this is taking like, I don't know, maybe 3 or 4 seconds, and then we lose sight of the target while we're moving to that location, instead of continuing to move to that location, this will abort, and we'll go back to roaming. Or you might have another branch in between which might say, look at the last location that you saw the player or something. So if this aborts, all we need to do is we just need to get this force timer ref, and we just need to say clear and invalidate timer by function, so that this won't continue to function once this task is closed, and then we should just be able to finish abort rather. So we'll say finish abort, not execute, and then we can just comment that and say abort. Boy. Okay, that should be everything. So that's the chasing one, that's the roaming one. What else did I have set up in here? I might as well just go through it. So the patrolling system, I mean, that's honestly the same thing. So if you wanted to do the patrolling system one, is in this valid flying location again, is what you could do. Let me just see. So we don't even need that there, do we? Oh wait, no, yeah we do. Find valid location near the target. Yeah, and that's in here. Okay, so what you'd do if you wanted to set up like a patrolling point is you just have a new blueprint class of type actor, and this could be called flying AI patrol point. It's a long video, man. I'm just going to dock that. I might as well finish it though, like it doesn't hurt to just show this. I'm just going to put a billboard in, and that is going to be, I don't know, maybe like 300 units high or something. Doesn't really matter. And that can just be like that, that's fine. And now what we're going to do is, well, you know what, maybe I'll just have that in the middle. That can just be like that. Actually no, let's have it 300 units high, because what it'll do is it'll save you time later. So let's close that down, and in here, the actor to get the location near, we could have a select node off here. This is getting a little bit complicated for a single task, but you know, whatever. Off of this, we're going to need a boolean. So this can be called use patrol point question mark. So we'll plug that into this index here, which will change the type of that. If this is set to false, it'll use whatever actor we've given to it by the key. But if it's set to true, then what we're going to do is we're going to create a little thing that'll get us a patrol point. So how the hell are we going to do that? Let's create a new function within this function, which will be get random patrol point. To be honest, maybe that should go up in, oh yeah, that is in here, isn't it? Yeah, so this is getting a location to test. So what we'll do is, when we're getting a random patrol point, I'm sorry if none of this makes any sense, like feel free to stop the tutorial at any time, we've covered most of it, but this is just a little bonus on the end. So when we get a random patrol point, we want that to be a pure function, or maybe we don't. Oh, we'll try a pure function. We're going to say get all actors of class, and that's going to be of flying AI patrol point BP, and then we're going to say get a copy. So this is getting a random one. We're just going to say get the last index there, and we're going to say random integer. We're getting a copy of the random integer in range. The minimum is 0, the first entry, and the last random integer is the last index. So now this will return a random patrol point, and we might just say, oh, actually, so what's the type of this? Flying AI. Okay, so we can say get billboard, which was that thing that we put up 300 units high. Instead of calling it billboard, let's give that a better name. Patrol point billboard. Just so that it makes more sense when you read it. Patrol point billboard, get world location, not actor location, because this isn't an actor, it's a scene component. And then we just need to have a return node over here. Oh god, not a freaking sphere trace. Return node. And then we plug that into there. And that will be location of patrol point. And then I can close that, and then, oh no, we don't want the location, my bad. Let's get rid of that. Let's destroy that, and then just plug the billboard. No, we don't want the billboard, we want this. I think, just like that. We're going to have to do a little bit of shuffling around, I think, because this is wanting an actor. Maybe what we could do is we could just say get actor location there. This could be broken like that, and then we could say break vector, and that vector can go in there. So now that vector goes in there, and then we can say get, we can set this up the way that we had it before. So this will need to be get billboard, billboard, get patrol point billboard, and then we'll say get world location. Hopefully this actually works. I feel like I just shuffled around a whole bunch of things and potentially ruined the whole task. Okay, so what this is doing is this is selecting, maybe I can rename this so we can call this use patrol points rather than actor key. That's a lot more descriptive, and we can make that public. Okay, so what this is doing is this is selecting a location of either an actor or a patrol point, depending on what you've set this to. If this is set to true, it's going to select the patrol point. If it's set to false, it's going to use whatever actor you've given it here. Then what it's doing is it's getting the location. Oh, it's getting the location of them there, and it's putting the location through here. It's stripping out the Z value, and it's adding whatever elevation you've specified in there, and then that's adding it to all of this stuff, blah 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 blah, and then it's testing it just like it normally would. So if you wanted your AI to patrol between like the different points, is what you'd do is when we've got this random roaming sequence, if we wanted this to be patrolling instead, you'd set the added elevation to 0, the min distance from the point would just be 0, and I don't know, maybe like 10 or something for the max distance, add a little bit of deviation, or maybe like 100. And then debug type is none, the move to location key doesn't matter. What is that used for actually, the move to location key? Is that even used in here? Yes? Sorry, my brain's not working too well at the moment. What's the move to location key for? Oh, I guess we set it at the end, don't we? Yeah, we set it at the end, we don't set it at the beginning. So I wonder if we even need to have that public. I might just make that move to location key output. Yeah, well, okay, so it does need to be public because you need to specify which one you want the output of this to go to. So we want the output location of this to be the move to location key, like that. So it's helpful to make that as output, because if you don't put output, then you're going to think, okay, I need to set something for this when you look at the task, but you don't need to set anything. You just need to decide where you want the information to go. So the next thing, the actor to get the location key, the actor to get location near key, that doesn't matter what we've set if we set this to true, because we're using the patrol points rather than the actor key. So now the added elevation, if we leave that to 0, we should be able to hit save like that. Let me just disconnect this, because we don't need to worry about if we're chasing the player. And let's just add in some of these patrol points. So these will be the points that the AI will patrol around now. So there you go. They should just keep going back and forth between those different points, provided that they can see them. So if one's been blocked by another actor, then it won't go to that one. So there you go. Look, they're just patrolling those points. Isn't that dope? Hopefully all that made sense, and like you could add as many of those in as you want. And the way that we've set it up is it'll get around a point, it'll check if it can see it, and then if it can't, it'll just abort, or it'll try again, sorry. It'll go back through this loop and it'll try again. So you could have a ton of these in, and it'll only ever move to the ones that it can see. So if you had like, you could just put in a bunch like this, and then you could add in like a bunch of obstacles like this. So put this here, like that. So that's blocking the view from some of them. But if I put this one over here like that, it'll never try to move from this point to that one because it can't see it. But what it might do is it might move to that one, and then it'll either decide to move to this one over here, or this one here, or this one here. And if it moves to that one there, then it'll go from there to there, or there to there, or there to there. But it'll always have somewhere to go, and it'll just kind of randomly choose and go around. So if you had like a big map full of different obstacles everywhere, you'd put these in kind of like the main points where like you'd expect it to want to wander to, like the junctions between like different obstacles where there's like a bit of open space. So I think that's pretty much everything. Hey, like that's working pretty well. So he's gonna just patrol like that, and you could set elevation above that if you wanted to. And when you reconnect this here, when they see the player, they'll start chasing the player instead of, oh god, I just fell off the edge. He'll just chase the player instead of going to his points. Which I don't seem to be doing right now. Okay, look, he looks like he is, but now he can't see us because he's not looking at us. So what you'd want to do when he was seeing the player is you might want to put another sequence node down here. And for this one here, instead of updating the path to face the direction that you're heading, set that to false, and you could have a parallel node like this. And then I think in a previous one we had rotate to face blackboard entry. What's the blackboard? Can I open that up? It's not going to let me open that up. Rotate to face blackboard entry. I don't know, I think you can set that to the target. If you can set that to the target, then you'll have the actor facing the target rather than where they're going, so it'll look at you while it's facing you. But okay, so that, yeah, look at that. They're both looking at me, except they're not doing anything in the meantime. Which I guess is because that's just an... I wonder why it won't let me open it up. Rotate to face. You're to face target parallel. Okay, let's use that. I wonder what the hell that other task was. That was weird. You're to face target parallel. This was set up in my Guardian tutorial, by the way, so if I open that up, this has just got a timer which just sets the yaw of the actor, the controlled pawn, to just face whatever target you've given it. So, and it's designed to work in parallel, so it'll work while you're moving to locations near the player. And you can toggle the alpha, so let's just set that to like 0.1 so they're like a bit smoother. And the target key needs to be the target. So now when they spot me, there we go, he spotted me. And he's yawing to face me, but he's not doing the pitch because that's just how I've set this up. So he's just going to constantly be facing me while he's chasing me like that. Okay, and he over there just got smacked by the other one, and now his rotation is all fucked up. So in order to avoid that, what you might want to do is well, you could change the angular damping up to like really, really high. So in this physics move to thing, maybe that's not high enough like that. But what you could also do in the physics move to component is you could use an event tick. And if you never wanted your guy to pitch or roll or whatever, is every frame you could just say set actor rotation. Or rather than actor rotation, is you could probably get the capsule. where is it, components. You could probably get this capsule, or you could get like the mesh or whatever. Well, it's the capsule that's simulating physics, so what we'd want to do is we'd want to say set world rotation here. And you'd want to get the world rotation because you don't want to be completely botching it every single frame. And then what you do is you keep whatever you wanted. So if you wanted to only ever have it yaw and never pitch or roll, then every frame you just set it like that. Just make it yaw, and then reset the pitch and roll to 0 every single frame. So that'll stop it from getting knocked about and looking in funny directions. But maybe you don't want that. Maybe you just want it to go normally. Maybe what you could do is you could invent a check to see if it got knocked off course when it wasn't supposed to be knocked funny and whatever. You get what I'm trying to say. Like, this is just to stop it from rolling around and acting weird. Now in this task here is what you could do as well, is this is only set to yaw. You could also create a boolean switching thing here which could include the pitch and the roll to look at the player as well. So while he was chasing the player like that, instead of just yawing to face, you could have him looking down and pitching as well. But I'm not going to do that now. I might do that in another tutorial. So next tutorial I might do the Skywatcher Guardian AI. So what that's going to do is that's going to integrate the Guardian tutorial that we did with the sniper beam and all of that, and it'll integrate this flying AI. So what I'll do, we won't use a whole lot of new logic in that one. It'll just be using the behavior tree tasks that we've already built and then putting them together to make a Skywatcher Guardian that flies around, and while it's flying around and chasing the player, it'll put the sniper beam on the player and blast its beam and kill everything in sight. If you haven't played Breath of the Wild, by the way, it's a fucking amazing game. It's probably my favourite game that I've ever played. Like, it's completely different to everything else, dude. Like, the freedom that it gives you to kind of run around and do whatever you want, and how cool it feels when you discover shit. Like, you can just spend hours and hours and hours on it. It's just amazing. And the AI is really good, and the way that it's like systemic and everything affects each other, and you can come up with, like, I don't know, cool strategies where you set shit on fire and then that burns some dude far away, or you shock something and you electrocute the water and you can kill everything in the water, and there's just so many creative things you can do with it. Anyway, so that's it for this one, guys. If you have any questions about any of this, drop me a comment. I hope this was helpful. Like I said, we'll do the Skywatcher tutorial next, but I think that's all I have to say for now. So peace out, guys. Thanks for watching. Hope this was helpful. This is unrelated to the actual tutorial itself, but if you'd like to support me in making these sorts of things, I've got a link now in my description where you can make a donation if you'd like to help me make more of this stuff. Unfortunately, I don't have anything for sale just yet, but I'm planning to get to work on making some new blueprints and things like that I might put up on like Gumroad or something, or I don't know. I'd like to start some sort of way that I could make a little bit of income from this so that I can allow myself some time to do more of it. So if these tutorials are helpful to you and you have the means to support me, like, don't feel guilty or anything like that if you can't. Like, I'm happy to do this for free in my spare time, but if you'd like to support me making more of these things, then there's a link in my description where you can make a donation from PayPal, and I would enormously appreciate that, and it would help me a ton. So thanks for watching, guys. That's it. I'll see you in the next one.